All right, here we go. This is the Unit 4 test review. And before I kind of jump into um, the main Unit 4 stuff, let's just talk about these functions that we've mentioned all throughout. This entire unit was all about graphing um, trig functions, right? So we have sine, cosine, tangent. Those are kind of the three main ones. And then we have the reciprocals. We have cosecant, secant, and then cotangent as well. All right. So let's just kind of identify. Let's see if I can zoom in this one. I can't. All right. So let's just identify everything that's kind of going on here. So this first function here, this red kind of curve, is a sine function. Right now, the sine function, there's kind of like five main pieces that we talk about. So if I just look at this thing, if I click on it, you can kind of see all those like special points that pop up. And the sine function, right? It always starts at 0, and then it kind of, if you follow my cursor here, it kind of goes up. It hits this maximum. This maximum is at pi over 2, and then it comes back down. It crosses the x-axis at pi, then hits 3 pi over 2, and then finally ends at 2 pi. All right, so what we did is we highlighted one period. That's like one cycle. Now, if I zoom out on this thing, we can see that it does go on forever. All right, so the sine function, it's going to go from negative infinity to positive infinity. That's what we call our domain, right? That's one of those kind of key words that we used here. So the domain of your sine and your cosine functions is always going to be negative infinity to positive infinity, right? Now the range, we talk about how far up does it go and how far down does it go. Right? And what I've done here is I've kind of made two lines. So that top blue line, that's our maximum. This green line, that is our minimum. All right, the sine function is between +1 and -1. All right, so it bottoms out at -1 and it maxes out at +1. That is our range on this function. All right, so if we go back to highlighting, all five of these points, right, that is the length of one period. How long is that cycle? How long does it, take before it repeats itself? Let's see here. What else can we say about this? We have our maximum, we have our minimum. Halfway between those, this purple line, we've been calling that our midline. All right. Now, the distance from this purple line to the maximum, all right, so kind of, the top point there, that is what we call the amplitude. Now, this function, the sine function, has an amplitude of 1. All right, now keep in mind there's two squares here, but, look at our scaling off to the side. Every sine function has an amplitude of 1. It goes 1 above the midline, and it also goes 1 below the midline. All right, so that's what our sine function looks like. Now, if we look at our cosine function, looks a little bit different. All right, so this one, it starts out at the very top, and then it starts to go down, crosses the x-axis, it bottoms out, crosses the x-axis again, and then it hits its maximum. All right, that is one period. Now, if you notice this one, it also has a period of 2 pi. All right, so it starts at 0 and it ends at 2 pi. It starts at its maximum, it goes down, hits its minimum at an x value of pi, and then it finishes off at 2 pi. So if we kind of compare these two, the red one is our sine function, the cosine is our blue function. They look very similar, but they just basically have different starting points. Right? So cosine starts at 1, right? And sine starts at 0. Right? Let's see here. And then the last one we have is the tangent. Tangent looks kind of weird. Tangent, it starts at 0, right? And then basically what happens is it goes up, right? So it's going to go up. It hits a vertical asymptote, all right? This asymptote right here, I can type that one in. I'm just going to say x equals, this asymptote takes place at pi over 2, right? And here's what I'm doing. I'm going to put a k here. Nope, that's not going to work. I don't know how to represent that, but let's see here. There is an asymptote at pi over 2. There's also one at every odd number pi over 2. So there's going to be one at 3 pi over 2. Right? And then there's going to be another one at 5 pi over 2. Right? There are all these vertical asymptotes going on with this tangent function here. So it starts at 0, and then it kind of goes up. It hits a vertical asymptote at pi over 2, and then it starts back at the bottom, and it's going to cross at every interval of pi. So 0, pi, this next one over here is going to be 2 pi. So it kind of goes up here. It almost looks like a cubic function, if you remember those from algebra 2. All right. So let's see here. Let me get rid of all these asymptotes. Let me get rid of the tangent here. The next thing we talked about was the cosecant function. All right, now this one looks kind of weird on its own. And when we graph a cosecant function, we never, try to graph it as is. What we do is we graph the reciprocal, which is the sine function here. All right, so what we do is first things first, we're going to graph this sine function. And then notice how it's crossing at 0 at certain points. Here's what I'm going to do. I am going to draw in asymptotes at those specific spots. Right? I'm going to put an asymptote right here where it crosses 0. I'm going to do another one at 2 pi. And then I'm going to do a third one at 0. Right? So these are those kind of vertical lines I'm putting in here. Now, what I can do is I can make those U shapes. And if we look at our cosecant function, everywhere we drew that vertical line kind of turns into an asymptote when we are talking about the reciprocals here. So the cosecant function, anytime you want to graph a cosecant function, all you need to do is originally graph your sine function, plot those vertical asymptotes wherever that sine crosses 0. You just turn it into a vertical asymptote, and then just kind of make these U shapes here. So notice how, if you look at the cosecant and the sine, they intersect at these spots that we have. So just all you have to do is really graph the sine, make those U shapes. And the same thing is going to hold true for the cosecant, right? So if we look at the cosecant here, if we look at the secant function, all you have to do is draw your cosine function. All right, and then let's see here, we have a vertical asymptoted pi over 2. I see there's going to be another one here at 3 pi over 2 because that's where it's crossing 0. So let's call this 3 pi over 2. All right, and then if we wanted another one, there's going to be one here at 5 pi over 2. So graph your cosine function, get those vertical asymptotes, and remember the vertical asymptotes are always where cosine is going to cross 0. And then just make those U shapes, the cosine and the secant function, those U shapes, they intersect kind of at the bottom and the tops, right? One last thing to mention on your secant and your cosecant is the domains on these things. All right, anytime you have a vertical asymptote here, you cannot include that in your domain. So this cosecant, let me get rid of the cosine. All right, notice how we have these U shapes. This dotted line right here, this vertical line is not dotted, but this vertical line here cannot be included in your domain. So when we're graphing our domains for your secants and your cosecants, you cannot include these vertical asymptotes. All right, so you would just say, hey, x cannot equal pi over 2, x cannot equal 3 pi over 2, x cannot equal 5 pi over 2, and so on and so forth. So if you look at these asymptotes, they are like odd numbers of pi over 2. So 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi, 9 pi, right? Any odd number in your numerator, let's put a pi over 2. That cannot be in your domain here. Right? The range on these things, notice how it's a U shape. So the range does not go in between these two lines. So when we're talking about the range, if we go all the way down, right, these things, they go all the way down to negative infinity. And then what's going to happen is it kind of comes back up and it stops here at -1 and it starts to turn around. Right? And then if you look up on this top U shape, it goes from positive infinity, and then the lowest it gets is +1. So your range on these secant and cosecant functions goes from negative infinity to -1. Right? And then what we do is we say union, and that means it kind of skips over all of these numbers in between the two horizontal lines. It skips over everything between -1 and +1. It's going to start back up at 1 and then go up forever. So your range on secant and cosecant is, oh, let's see here. It's going to be negative infinity to negative 1, union 1 to positive infinity. Right? So there's your secant and your cosecants, and then the last one is, I guess, your cotangent function, which looks kind of weird, but it's basically the tangent function, just kind of reflected. All right, it looks like instead of rising as it goes to the right, it kind of falls. All right, so if we look here, let's see here, what can we say? The tangent function, we said, starts at 0 and it has asymptotes at pi over 2. All right, if you look at the cotangent function, it has asymptotes, looks like at every interval of pi, and it crosses 0 at pi over 2. Right, so I think the cotangent is, the trickiest one to kind of see, but as long as you graph your tangent function, right, so here, let's graph your tangent function. We have those asymptotes where they should be, right? Those 0 points on the asymptote where it kind of crosses the x-axis there, those need to be the starting points for your cotangent, right? If I put the cotangent back on here, right, it's going to cross at those intervals here. And where tangent crosses 0, those become the new asymptotes for your cotangent function, right? So it's just a matter of shifting those asymptotes where we need to. So the asymptotes on the tangent function are at pi over 2, 3 pi over 2, 5 pi over 2, and that sort of thing. Whereas if we look at the cotangent function, they're at, let's see here, where are these asymptotes? There's a lot going on here. They're going to be at pi, 2 pi, 3 pi. So whole number pi values are where your asymptotes are going to be for your cotangent function. All right. So that's kind of just what these 3 graphs look like. If we were to put them all on the same graph at the same time, right, here's kind of the 3 main ones all together. But the ones that we've talked about the most in depth are definitely your sine and your cosine. And this unit was all about shifting them up, down, left, right. So let me just get rid of everything here. So if I just look at this sine function, if I graph a new one, I'm going to say like 2 sine of x, right? That changes the amplitude. So instead of being, 1 unit tall, it's now 2 units tall. If I say 2 sine of x minus 1, I shift the whole thing down 1 unit. All right, if I just change it back to sine, right? It's the same kind of height. It's just the whole thing gets shifted down 1 space. All right, if I take this and I say plus 3, even just plus 1, it's getting shifted backwards 1 unit. If I do minus 1, it's getting shifted forwards 1 unit. If I put a 2 in front of the x, that affects the period. So it's happening twice as fast. Notice how the red one is kind of our original, the green one is the new one. Notice how the green one, it's twice the frequency, all right? So there are 2 cycles of the green one within 1 cycle of the red one. So that number in front of the x changes the period. If I were to put a negative sign in front, just shifts the whole thing, or doesn't shift it, it reflects the whole thing. It kind of turns upside down. So let's see here. If I do -2, I'm changing the amplitude. Actually, no, let's do -0.5. Right, so it's kind of scrunched. All right, -0.5. If I put a 2 in here, that increases the frequency. If I put I don't know, a plus 3 in here, shifts the whole thing to the left. And then let's say -4. Now that won't fit, -1. It'll shift the whole thing down. All right. So that's what we've been basically doing this entire time. We're just moving the graphs up, down, left, and right. And that's the bulk of the unit we've been doing is with sines, cosines, and tangents, and your reciprocal functions. Right. So that's what this unit was about. So in the next video, we'll just look at all of the examples.